In the year 1816, there was a giant volcanic eruption that put a ton of dust into the atmosphere. This cloud blocked sunlight from coming in, cooling the temperature and making it the year without summer. But why did all this dust in the air affect how warm Earth got? To understand this, we need to begin talking about the atmosphere. The atmosphere is the shell of gases surrounding Earth. Now down here on the surface of the Earth, we breathe in air. What is our atmosphere down here made of? Take a look at this chart from our reference table, page 1. You'll see that our troposphere, which is the name of the air down here on the surface, is made of 21% oxygen and 78% nitrogen. The other 1% are other gases that make up the air around us. Now the composition of our atmosphere down here has remained pretty much the same throughout Earth's recent history in terms of geological time. The reason for this is our planet is an efficient recycling system. The recycling system looks something like this. Plants take in carbon dioxide for photosynthesis and release oxygen as part of that same process. People then breathe in that oxygen, as well as other animals, and exhale the carbon back into the plants. Also, water vapor enters the air through transpiration, which is when plants release water in the air, and when humans or other animals breathe, there's water vapor that enters the air as well. Water also enters the air through things like evaporation, which we'll talk about in a later lesson. As you go farther away from Earth's surface and up into the atmosphere, the temperature is going to take a turn. Scientists divided these areas into 4 different layers. The troposphere is the lowest layer and the air that we breathe here down on the surface. The next layer on top of that is the stratosphere, which has the ozone layer, which is what absorbs the sun's harmful rays. The layer on top of that is the mesosphere, and on top of that the thermosphere, which will have different things like shooting stars and these northern lights. This graph here is from page 14 of our reference table and will show us the temperature at different levels in the atmosphere. The graph on the side is altitude, which is height in kilometers as you go higher up, and this is the temperature down here, which will show us as you go to the left side it gets colder and to the right it gets hotter. So in the troposphere, as you go up, it's going to get increasingly cold until you get to this point called the tropopause, which is the boundary between the next layer. As you go up in the stratosphere, it's going to get increasingly warmer until you hit the stratopause. The mesosphere is going to get colder as you get higher, and the thermosphere is going to get warmer as you get higher. Using this graph, you can tell what temperature you're going to have at any particular height in the atmosphere. Now, as we mentioned in the beginning, the sun is going to heat Earth, and the energy from the sun is essential to almost all life on Earth. So, how does the energy from the sun reach all across space to us here on Earth? To answer this, we first need to understand the 3 ways that heat energy is transferred. The first way is called conduction, which is through a solid. For example, when you touch something hot, that heat is transferred to your body, which is a solid. The second way heat transfers is called convection, through liquid or gas. For example, when an ice cube melts in warm water, the heat from the warm water transfers to the ice cube, causing it to melt. The third way is called radiation, through visible light. For example, a fire, or the sun. The sun gives heat to the Earth with radiation, and this is called insolation, which is short for the words incoming solar radiation or sunlight that heats the Earth. So what happens to the energy after it reaches Earth? This is called the heat budget, and looks something like this. It says that whatever amount of solar energy that comes into the Earth needs to be eventually released. The ground and water will absorb some of that energy and then release it. In the meantime, some gases on Earth are going to trap some of the heat in our atmosphere, keeping us in our atmosphere nice and warm. These gases are called greenhouse gases.
Did you know that gases in our atmosphere help control the Earth's temperature? Greenhouse gases, like carbon dioxide, trap heat in the atmosphere and keep the Earth warm. This is called the greenhouse effect. It all starts with sunlight, which is a form of energy. Land and water absorb most of the sunlight that reaches the Earth. The rest is reflected back to space. The Earth's surface warms up. then gives off energy in a different form, called infrared radiation. This energy travels back towards outer space. Greenhouse gases trap some of this energy in the atmosphere before it can escape, making the Earth warmer. We need some greenhouse gases. Without them, our planet would be too cold for plants and animals to live.
That's all you need for today. Next in this series, we'll continue to talk about the atmosphere, the temperature changes in different parts of our atmosphere, and pollution. Please answer the questions in the form below and hit the submit button. Thanks so much for watching. Have a great day.